Yo, all right. Thanks everybody for coming. My name is Brian Fox. I'm one of the co-founders and the CTO at Sonatype. My background is in development, C, C++, and then Java, as well as Maven since the early 2.0 alpha days. And so we've got some of the other Maven committers and PMC members here too. So if you hate Maven, well, join the club, I guess. But you could talk to us about it. So I'm here with Olivier.
Yep, I'm Olivier Routier. I come from EDF, and I here to explain how we use IQ Server in our company.
Right. He's going to talk about struts and what happened to you guys, right?
Yeah.
So I'm sure. How many people here are using struts and are willing to admit it? Nobody. Okay. There's always somebody who's actually using it. So just a little bit of background, and it will explain the context, right? Since I said we've been involved in Maven since the beginning, you could see sort of the progression of some of the things we've done here. And Sonatype is the company that manages the Maven repository, the Maven Central, right? So that provides us some unique insight into what's going on in the ecosystem over the past 10, 12 years. So this shouldn't be surprising, but this is a quote from Don Duet at Goldman Sachs, right? And talking about the importance of open source and how it underpins so many mission critical systems, and that focusing on using the right components is really key to be able to making sure that those systems stay in place. And so that's what I'm going to talk a lot about today. So I think this is probably obvious for this audience, but why are we using open source components, right? It's because it allows us to gain massive productivity increases. It's the same as when we shifted to an assembly line for building cars and things like that, that the quality went up, the speed of delivery went up, and the price went down, right? So that's why we use components. Maven helped, really kind of enforce that or make it easier to do, at least within the Java ecosystem, in terms of binary reusability. And Sonatype does a yearly study. We're working through the data, and the new one will come out soon. So these are somewhat old numbers, but they show that obviously we're feasting on a massive supply of these components. Now this is the increase of component consumption over the Maven Central going all the way back to when we started the company. And actually in 2016, the number is 57 billion, right? So the growth continues to go significantly up and to the right. And it's not just Maven, this is the module counts website, and you could see all the different ecosystems are taking off, especially as they have reusable components. Languages that have good package manager systems tend to be adopted faster for, I think, this reason, right? And the key to note is that there's thousands of new projects every day, tens of thousands of new versions of those things every day, and on average they change 14 times a year. Now, those components are not all created equally, right? Some of them are good, some of them are horrible. Now, we've looked at statistics of the top 3,000 organizations that participated in our survey, and these are the numbers that we see, right? So of those top, they're consuming 229,000 components in a given year. That's quite astounding. There's 5,000 different components typically. This would be in Maven terms the GAV, right? And then the GA, the artifact, 2,000 different components, right? So clearly there are not 2,000 different categories of components, so lots of these organizations are using way too many XML parsers, way too many different loggers, way too many different UI frameworks, et cetera, right? But what's somewhat interesting is that of those being consumed, typically nearly 8% of them have known security vulnerabilities at the time they were pulled from us, right? So it means people continue to use and consume these very old components even when they've been publicly, disclosed to be vulnerable. Now, I'm a developer, like I said. I hear a lot of people say, well, that's because developers lazy, and that's not really true. The problem is really that most of the time, nobody knows. It's hard to find out what versions actually have vulnerabilities, right? So there's sort of this communication gap between the open source projects that are fixing it and shouting from the mountaintops, you don't use this version, use this other version, and then 10 years later, people keep using struts. That's completely hackable. And again, it's a communication gap, and it's an awareness gap. And so I'm going to talk about that. But first, one of the things we hear quite often is that companies will say, but we got this under control, we don't have a problem. And these are statistics that show that's really not true, right? So 6.1% of the downloads are vulnerable, and you see that it's basically the same percentage all the way into the finished application. So if the things they were doing today actually worked, you would expect this number to get smaller. You know, they download a bad thing, they kick it out of the repo, and they don't put it in their application, but that is emphatically not the case. And I think that's because a lot of the people that are managing IT sort of cut their teeth in the days before components were the primary use case, right? So they're thinking that all of the code is custom code, so I'm going to do things like static analysis and catch these things. And the realities of today's ecosystems, that's just not true. The typical application these days is made up of 80% open source components, 20% custom code. So it's quite literally the iceberg, you know, the thing that's under the sea is the thing that really will kill you. So I think we all know this, but I love showing this picture anyway. Developers love the transitive dependencies. And so this was an analysis of all the things in Central a couple years ago, and it's a pretty interesting web we've woven. Right? So this just sort of further makes it more complex when you're trying to deal with, are the components I'm using good or bad? You know, your developers are picking one thing, which is going to pull in 100 different things, and they're probably not checking the quality of all of those things. It's mathematically infeasible when you're at the scale of you've got 229,000 components. You just can't do it. Now, if we switch for a minute and we think about what the attackers are doing, right? In the old days, when all of this was custom code, it was like finding a needle in a haystack. You literally had to break each application. And this is why you see classes of violations or vulnerabilities, because they would look at an application for, can I exploit this via SQL injection, right? And just try it. But nowadays, that we're reusing all of these components and we're assembling them, this basically becomes a shared attack surface, or you know, a common mode failure across all of these things. And so for the attackers, all they have to do is figure out how to, for example, exploit struts, put it into one of these script kiddie hacker kits, and go to Google and search for .do, right? And now you can just find a wealth of targets and exploit them. And we see this a lot, that nearly immediately after the vulnerabilities are disclosed, people start getting attacked. And in both of the struts cases, the one that just came out a few weeks ago, as well as the one that was 5 or 6 years ago, a lot of big banks got attacked. They won't admit that they were you know, attacked because of struts, but the timing is somewhat suspect, if you ask me, right? And you know, the Commons Collections vulnerability that came out like last year, there are still companies that continue to get exploited by that. A couple months ago, there was a hospital in the United States, in California, that got subject to a ransomware sort of thing, with all their records were locked up, and they eventually traced that back to Commons Collections. And there was also an issue with one of the subway systems as well, right? Again, something that was disclosed, fixed in 2015 is being exploited in 2017. Why? Because we haven't closed that communication gap. So the good thing, from my perspective, is, you know, our profession, we don't have to invent this problem from scratch. This is a well-solved problem. When you start to think about these components, these binary things, as parts, and you translate it to these types of things, where you have well-defined, well-expected supply chains, all we have to do is start thinking about it and look at what they've done and how they've become more effective. And I like these examples that are up here. I don't know if this is a model that you guys might recognize here, but that's the Chevy Cobalt. And a couple of years ago, they had like the classic configuration management problem. There was a flaw in some of the ignition switches that when you had a heavy keychain, it would shut the car off while you're driving. And so if you suddenly lose power steering and power brakes and you don't expect it, that can be a problem. And unfortunately, some people died. But the real tragedy there was that they made a modification, a patch to the ignition switch that fixed this, right, before, you know, it was widely disseminated. But they didn't rev the version number. So in the end, in all of these parts bins, in all of these cars and these manifests, they all had the same version number, right? So that's like the equivalent of just re-releasing the same component and not revving it. So, you know, it just further shows that some of the things we know are good, you know, sometimes maybe they should do the same thing, right? And we know about supply chains and tracking food and things like that. So it's really key, right? So if we think about what do, well, they do a couple of important things. Anybody in here familiar with Deming? Right? So you know where I'm going with this, right? Deming helped rebuild the Japanese auto industry after World War II, and he was, he did a lot of study on supply chains and workflow analysis. It's sort of the same thing behind the Phoenix project, right? And thinking about the different flows and stuff like that. And it really boils down to 3 key concepts. The first one is use fewer and better component suppliers. So this is sort of goes back to that slide where I had all the numbers. You don't need 5,000 different components in your organization to do maybe 20 different jobs. So you want to shrink down the number of different things. So reduce the surface area of XML parsers and UI and persistence, because it will be easier. The side effect is your developers will be able to move around projects more easily because you have the same technology in there. Within that, you want to make sure you're using the highest quality parts. Don't ship the old ignition system that's broken, right? Don't keep using struts. So even if you pick a good project, you still have to pay attention and make sure you're using the right version of that. And then lastly, you need to continuously track the bill of materials where those are used, because no matter how good a supplier is, problems happen. What's most important is how quickly can you remediate that? Because remember, the developers, the hackers basically have the first mover advantage. All they have to do is watch the disclosures and they can start attacking on day one. If you're not ready to start remediating that in your application for weeks, that's a pretty big exposure time. And that's where we see most of the attacks happen. Now, in order to do this effectively in a modern development ecosystem requires some care. So over the last 10 years, as I've kind of been helping customers with this, there's some things that I've figured out. So that's what we're going to talk about. But primarily, some of the tension that we see in these processes are due to the fact that we've, over the last 10, 15 years, really aggressively shifted how we develop software, right? There's the old waterfall, then we started talking about Agile Development, and now we're talking about continuous everything, right? And so the net impact on that in terms of the number of releases is astronomical. Instead of a couple releases a year, have hundreds or thousands and some unicorns a day. And so what is the impact on that from a governance perspective, right? Where it used to be possible to have a human review board decide what components should be used for the applications because they had months during requirements gathering, now there's pretty much no time because a developer can make a change, check it in, it runs through the process, and it's in production minutes or seconds later. So you need to be able to really think about how am I going to catch, the next struts problem? What am I going to do about it? And many companies still try to go back to that manual process, right? They say, we're going to require all developers to get approval before we let them use it. And so one of two things every time happens in those ecosystems. Either they're not good at enforcing it, so it's just to check the box, and then the developers work around the process, so it's just not really helping anything. Or they're really good at doing it, and the developers just throw their hands up in the air and go, forget it, you're paying me to build features, not to fight you to update struts. And this is also part of the reason why we see, on average, people using very old components. So it's sort of ironic, right, that companies that are trying to reduce the risk are unintentionally increasing the risk, either by slowing down the innovation or just forcing developers outside of the observable channels. And when you really think about that, that is the primary evidence for the fact that their process is not actually doing what they think. So these are sort of the 4 key things that I talk about, I think about when we're trying to figure out how to solve this. The first, early awareness. The sooner you can make developers aware of the choices, the implications of the choices, the better. You don't have to chase it down and solve it later. You need to be able to empower the developers with better information, right? So I'm going to talk a little bit more about this in some of the other slides. You need to be able to integrate across the lifecycle. You need to be able to continuously monitor these things because new vulnerabilities come out. So these are sort of the 4 key concepts, and I'm going to dive into those as we go forward. If you remember that slide that showed the cycle time and we're trying to automate, we have seconds maybe minutes, depending on a really big build, to be able to do an inspection without really impacting that quick cycle time of commit to deployment. So it means the policy system and the way you're approaching this has to be able to do analysis very quickly. It's not sufficient for it to take hours to run and then produce something that is not deterministic and not automatable. Because what good is a giant spreadsheet that nobody looks at, right? It's not actually helping. So automation of a spreadsheet is not really automation as far as I'm concerned, right? And the way you need to do this is think carefully about what are the attributes of a component that make me not want it, right? It could be the license, it could be the presence of security vulnerabilities, the age, the popularity, whatever it is. Figure out what that is for your organization and then figure out how to automate it. And then there's always these edge cases. Only feed the exceptions to the humans. It's really the only way to be able to scale this without all the unintended consequences I talked about before. And so what that looks like in the end is this, right? So now you're able to actually do this all the way around the continuous development cycle and make sure that you trap this stuff. So you don't have to choose between going fast or sleeping at night. Now, it does us no good if we're automating a bunch of noise, right? Developers hate noise. It's like the fire alarm that keeps going off. What happens? You ignore it. So, I used to use this, and every time I was updating the slide, and then I got tired of chasing the slide. Basically, every version of struts, except for that one right now, is exploitable. And so you need to be able to be very precise in the identification and creation of your bill of materials so that you can get the right information, right? So a lot of systems, a lot of manual tracking systems can't be precise enough to know exactly what version of a component you're using or which submodule of a component. And so a lot of times the tendency is to try and roll the data up just to the project, in this case like struts, right? Well, some vulnerabilities might only be present in one module. If you're not using that, you don't have the problem. So you need to be specific enough to know the difference and not throw that false alarm. And this sort of goes with it. You need to be precise about the identification. We had one customer tell us about a tool they used that produced 50,000 findings. After they went through them, they found that there were 200 maybe findings. They still couldn't quite prove it. And he told his bosses, if you buy this tool, I quit. I'm not doing this. This is ridiculous, right? So if they did buy the tool, basically that's what his desk would look like, right? It's just going to get a pile of stuff that gets ignored. So people are spending money to solve a problem and then buying the wrong stuff and not solving the problem at the end of the day. Additionally, just because you correctly identified a particular component doesn't mean the problem applies in all cases universally. So you need to be able to be flexible in how you define your policies and your governance and while you think about it so that you could put your applications into certain categories and then put the policy to those categories, right? So the SQL one's obvious. If you're doing an internal service, copyleft is probably okay. If you're distributing it, shouldn't be okay. And we see different types of severity and remediation strategies for security as well. If you have an application that's dealing with credit cards, obviously that has a more strict set of requirements than one that's just like a calendar app, right? So again, it's similar to the imprecision and the false positives. If your stuff is not contextually relevant for the given developers on that team, it's a false positive. It's basically what it boils down to. Now, when you provide information to the developers, it needs to be actionable. It's no good to just throw stuff up and say, you got it wrong, fetch me a rock and try again, right? You need to be able to provide information so that they can understand the risk. Because ultimately, if there's an easy fix and it's obvious, I'm going to take it. And so this sort of comes down to things like vulnerability detection tools that merely just spit up the CVE information. What we found through our experience is that that information tends to be written only for operations teams or security professionals, right? So basically, if you're a developer and you've now got a tool that's trying to empower you with this information, but the information being shown to you assumes knowledge that your typical developer doesn't have, you haven't really helped. And worse, what you're forcing to happen in that instance is the developer is making a judgment call on something that they're not the expert in, right? And it's easy to convince ourselves, it's probably not going to happen to me. It's probably not exploitable. Nobody's going to really blame me for that. I got a feature to do, right? So if you make the information too hard and force them to make the judgment call, they might make the wrong judgment call. Otherwise, if you say, look, if you're using 2.0 and it's got a level 10 vulnerability in it, but 2.0.4 doesn't, who wouldn't go that route, right? Because at the end of the day, developers really do care about the quality of the stuff they produce, even though everybody above us thinks we don't. So again, that's the empowerment part of it. And lastly, applications, don't age like wine, they age like milk. So you need to be focused on, keeping on top of those, because there's always new vulnerabilities coming out. The past few years, the rate of vulnerability disclosures has really taken off exponentially. And so this is important. And, again, a lot of those manual processes, what we see are people will analyze a component at the time a developer says, I need it. And they'll look at it and they'll go, okay, it's good. And then they put it in this bucket. And then the definition of good is components in these bucket. Well, that's what leads to people using these old versions years later. I used it because it was in the approved list, but nobody is going over those 230,000 components a year checking to see if they're still good. So you need to be able to automate this. All right, so how this fits together in real life. This should hopefully be familiar to most people in here. This is what we call a software factory, right? And companies that we see being really successful at doing a lot of these practices are ones that tend to set these things up. Companies that struggle with this are the companies that have no centrally defined repository, no centrally defined CI systems. If you've got 50 different CI systems and they're all managed by developers, and nobody knows what's going on, you don't have a software factory. You have maybe a software bazaar or something. And so, the flow, obviously developers will check out the code. They'll build it using something like Maven, which is going to fetch the components from the repository, which gets it from Maven Central. And then they check in the code, right? That's pretty straightforward. Then hopefully you have a CI system that's doing basically the same thing. And this may repeat, multiple times if you're a subassembly. But at some point, the best companies will have some form of deployment automation via Rundeck or Puppet or Chef or any of those types of tools that will pull those finished goods out of the repository, push them off to development, QA, testing, and ultimately production, right? So this is pretty typical. On the left is what we've always talked about as CI, and on the right is CD. Now, all of the things that I talked about sort of fit into this workflow here, right? So empower the developers early. So again, if you're showing them the right thing, they're not going to check in a POM or whatever with the wrong version of something, and you won't have to fight to pull it back out later. And that really is one of the most important things, because you can stop so many problems right there. Also, this is where you can bring information like what is the most popular XML parser or whatever, right? So providing that level of information also has the tendency to reduce that scope naturally. If everybody understands like, oh, this is the most popular thing, or being able to analyze them in combination. So what is the most popular notification framework with Angular versus one that works with React, right? That kind of information at this stage can be tremendously helpful. You want to make sure that things that are truly bad across the whole company don't even come into the organization, right? Why would you allow a component to come into the organization that's known to be vulnerable at the time it's coming in? That kind of doesn't make a lot of sense. But at this point is not the right place to enforce licensing or quality types of checks, because like I said, some applications might be able to use copyleft and other ones can't. The place to do that is in the build or in the CI system, because now you actually have the context of the application that's being built so you can evaluate it appropriately. Whereas at the repo, it often doesn't know. Maven doesn't tell Nexus what application it's asking a component for. It just says, give me this component. So you can do some global level checking, but not super precise checking. So if you followed those things, now your repository has good components, both third-party ones as well as internal components are now good. So you truly do have, the golden repository. but you need to be able to continuously monitor the things in there as well, because they're going to go bad. They're going to age like the milk and turn to cheese, right? At deployment time, you want to do policy enforcement and checking here as well. And this is key, I think, because what happens when you have the ability to have checks multiple places in the life cycle, it allows your response to those to be much more contextually applicable. The thing that developers hate the most is when tools break the build somewhat arbitrarily, especially for something that worked yesterday, now all of a sudden it doesn't work, right? So this would be the case of enforcing no security vulnerabilities. Well, you know, if there's new vulnerability overnight, you come in the morning and the CI is breaking, that's actually counterproductive. So being able to, for example, do a warn in the build is much more compatible with development, but you could still make sure somebody doesn't slip up and deploy something after the fact, right? So being able to do the same type of checking across the life cycle makes it much more compatible as well. And then finally, you need to be able to monitor for these new issues. It's pretty common that applications get built and sort of thrown over the wall, and then nobody develops them anymore, right? So organizations have hundreds or thousands of legacy applications that are sitting out there with problems in there that nobody knows about. I think you're probably going to talk about that. Yeah. And so, right about on time. Thank you. That's my part. Now I'll hand it over to Olivier.
So it will be my part, and I will present you how we put Lifecycle in EDF. So we have there are 3 weeks. There are information that a struts is again vulnerable to a security issue. So they have some problem in EDF because now processus doesn't check the package that is included in the application. We have a processus for the product, the system, but not for all the package included in the application. So the direction, because the CNIL was hacked by the security issue by struts, they want to know if we are impact. So the problem is the security team doesn't have the information which application have struts. It's not. It's nowhere. We have some tools to do inventaire, and but we doesn't have any information that each application, the framework used by each application. So we put in place IQ server, and the advantage of IQ server is that it will tell you that you use this version of strut, and like you can see, it's a version that is very old, and they have some security issues that is level 10. So the security issue that is that was response in 3 weeks. It was a 9 in security. So to create it, we must go to the version that is 2.3.32. So this is a report of an application that is already in production from more than 5 years in EDF. We can see that we have a lot of security issues. Then we have struts, and we have also some package like web service that is that are include security issue. The problem is we have a report, but if we want to correct it, je vais reprendre en français, ce sera plus simple. Excusez-moi. Donc en fait, on a un rapport sur la sécurité sur une application qui est en production depuis 5 ans. On s'est aperçu qu'en fait, on avait plein de failles de sécurité classées 10 sur 10 en termes de CVE. Et en fait, il y a Struts qui est inclus, et on a tout un autre ensemble de frameworks, dont des web services qui sont aussi impactés. Parce qu'en fait, on s'est rendu compte que toutes nos applications, on a beau utiliser des serveurs d'applications comme WebLogic ou JBoss, en fait, les projets, ce qu'ils faisaient, c'est qu'en fait, ils n'utilisaient pas les librairies embarquées par le serveur d'application, ils allaient en fait embarquer leur propre librairie. Donc nous, on a beau patcher les serveurs d'application, le problème, c'est qu'il y a quand même la faille de sécurité. On a eu le cas avec la Apache Common Collection. notamment qui est classé où vous avez dû lire des articles sur Internet comme quoi tous les serveurs d'application étaient impactés par la page connexion. Donc il y avait WebLogic, JBoss, peut-être pas Tomcat et WebSphere. Donc c'est les serveurs d'application qu'on utilisait chez EDF. Mais en fait, on avait aussi toutes nos applications qui embarquaient la fameuse Apache Common Connection. Donc en fait, on a utilisé Lifecycle, c'était pour nous faciliter en fait, parce que l'outil, il va permettre de faire des rapports statiques, c'est-à-dire vous allez prendre votre package, vous allez l'uploader dans l'outil, il va vous donner ce joli rapport. Mais en fait, si on se dit qu'on le fait après que le package a été généré pour la prod, c'est un peu trop tard. Parce que ce sera en fait pour la prochaine version que vous devrez corriger les failles de sécurité. Tout l'intérêt de l'outil, c'est qu'en fait, on peut l'intégrer directement à Jenkins. Comme vous pouvez le voir, en fait, soit vous allez avoir un rapport qui va être généré dès votre phase de build, et avec les failles de sécurité, donc vous n'avez plus qu'à cliquer dans l'outil, ça vous redirige en fait sur le rapport. Ou soit en fait, dans la version Jenkins 2, ce qui est plutôt cool, c'est qu'ils ont intégré en fait la pipeline syntaxe. Donc c'est plutôt pratique parce que ça nous permet de dissocier en fait l'analyse EQ server a posteriori. Et comme il s'était expliqué, c'est qu'on peut en fait mettre des règles, c'est que si les failles de sécurité ont détecté des failles de sécurité qui étaient supérieures en fait à 7, on pourrait en fait déclencher que le build il est en erreur. Donc ça c'est tout l'intérêt de l'outil. Il y a un autre intérêt aussi, c'est qu'il s'intègre très bien pour les développeurs, notamment avec Eclipse. En fait, mais il y a aussi un plugin pour IntelliJ. Ce qu'on peut voir, c'est qu'en fait, directement dans Eclipse, on va pouvoir, dès la phase de développement, donc de conception, intégrer l'outil. Et il va nous remonter en fait que, voilà, pour toute librairie qu'on utilise, il y a des failles de sécurité qui sont remontées. Et tout l'intérêt, c'est qu'en fait, on a une petite réglette, ce qui est plutôt sympa, qui va nous permettre de dire, bah voilà, il suffit juste de passer à une version bien spécifique. Donc vous pouvez choisir de passer sur une version, la toute dernière version avec toutes les pages de sécurité et en même temps les correctifs. Et en fait, il y a un petit bouton migrate. Et en fait, automatiquement, il va détecter dans le POM la version, il va vous migrer et il va vous télécharger le dernier package puisque vous êtes avec Maven. Et voilà. Donc ça permet au plus tôt de corriger justement tous vos problèmes de failles de sécurité. C'est-à-dire que vous pouvez avoir, avec l'outil, c'est que vous uploadez votre package et il vous fait un rapport de sécurité. Soit en fait vous l'intégrez dans la phase avec Jenkins dans votre intégration continue, ou soit vous l'intégrez directement dans votre IDE. Donc en fait, on n'a plus de raison en fait d'embarquer des failles de sécurité dans nos applications. Après, il y a un autre intérêt que je n'ai pas précisé à l'outil, c'est qu'en fait, il y a un petit bouton qui s'appelle View Details qui permet en fait d'avoir toutes les informations sur la faille de sécurité impactée. Des fois, là je vous montre, on peut migrer sur une nouvelle version. Ok, il va y avoir des impacts sur le développement et tout, il va falloir les estimer. Mais des fois, en fait, il n'y a pas de nouvelle version au niveau des frameworks. Donc dans ce cas-là, en fait, il y a tout un intérêt, c'est-à-dire qu'on peut choisir les actions à faire. Soit en fait, on se rend compte par rapport aux informations qui sont saisies qu'on peut mettre en place des règles de firewall, ou bien en fait, on se rend compte qu'on n'utilise pas la classe qui est impactée. Donc c'est tout l'intérêt.